Hello, everyone. My name is Darrell Huntsman. I'm the CEO of CO2 Sync. I bring a developer's perspective to this. And what's most important for a developer, would love to say that we're saving the planet, the climate. The most important is profit. Once we have margin, then we can work on the second part of our mission, which is all the environmental impact. So with that lens, that's where I'm coming from. What we want to talk about is automating dMRV for carbon credits, IoT integration, and biochar production for enhanced verification. I can see that title really packed it in today. We need to work a little bit on our marketing. So that sounds more like a PhD thesis. How do we get moving here? Okay, when I look at profitability, there are dozens of drivers, but there are four main drivers that I look at. The first is feedstock. Where are we, proximity to feedstock, cost of feedstock, processing it. We have to look at that. The second main driver is, are you producing biochar? Uptime of the equipment. Are you able to actually spend all that time producing biochar and effort producing biochar versus fixing machinery or doing something else? The third is labor costs. And how much of this can you automate? How much of that cost can you take out of it? And then the fourth is the top line. Are you producing quality biochar that allows you to have quality offtakes for carbon removal credits, for the biochar itself? And so that's what we look at. That's what I evaluate when I'm selecting different partners to work with. We have CARBO-FORCE as our technology provider for the pyrolysis. And it's been very, very successful for us. Where we are in our stage of growth, we say 3 phases here. We actually have multiple phases, but we'll go through 2026. We've launched our first plant. We have a second one that's in development right now. Our first plant will deliver just over 400 or 500 tons of biochar per year. The second is gets up to 4,000, and then phase 3 in 2026. With our expansion, we'll have over 17,000 tons of biochar per year. So that gives you a sense of that. For tracking and automating this whole entire process, we use Cula. From pulling it out of the earth to putting it back in the earth, we're tracking that whole entire process. When we looked at what we wanted from a system like this is, one is the interface, because multiple people will be touching it. Does it look good? Can we actually interface with it? And then the second is automating as much as possible that entire data collection process. Part of that automation is the integration into the solutions itself. So we have API connections into the technology so we can track it throughout the entire process. Our process, what is unique about us from a producer, there are a few things. First is our feedstock. We're mostly focused in the Mountain West. We use infested beetle kill forest as our feedstock. There is a significant amount of this forest available to us. And we set up locations that are strategically placed as close to that as possible. So we use that beetle kill forest, we chip it up in the forest, and then we bring it into the plant itself. Now, once we've done that, that's almost the end of our human intervention. We bring it in, we weigh the trucks, we then collect that data automatically, and it's integrated into the Cula system. Then we dump the chips into 3 separate bunkers, cement bunkers. And then we have a system, a top load system from AA Biomass, and that's automated. We're not moving chips from one place to another place and then staging it for drying and all of that. We just move it to one place, we put it in there, and then the pyrolysis system calls for it at a certain rate, and we're pulling that in it. That gets to the second part of this, which is the pyrolysis itself. The other thing that we've done to eliminate the labor and the input is we have integrated dryers into that. So we're not second staging it. CARBO-FORCE has an integrated dryer, and that way we can just move it straight in there. It's drying, it dries it out to the right moisture, and then we're pyrolyzing it. From there, I'll just kind of get to the end, which is then we off-take this. We have 4 separate trailers that we collect the biochar. Now that's important from a couple of reasons. One is that we need to have some flexibility in when those off-takes are coming. But once again, we're not having any humans moving material around. It loads those directly. The other is that we're not doing this yet, but it allows us to start to sort and size the different particles of different biochar by different units. And so we can start to be more customer focused. If someone needs a certain particular particle size or a treatment on it, we can load one trailer with that and another trailer with another. The other thing with our plant is that we generate about 500 kilowatts of electricity. So that allows us to have a third revenue stream for profitability. We consume some of that electricity for ourselves, so our system's completely self-sustained, but we generate significantly more electricity than we consume, and we sell that to, in this case, for phase 2, and partially phase 3, a local business that's right next door to us. So we track that entire process. And then we have a local off-taker that they mix it with their special formula, and then final input into the ground. From there, what we have is we've tagged that biochar with every bit of data that we have with it, and it's all automated. So we know that this biochar was produced on this date, with this moisture content, at these temperatures, with this type of chemistry, from this forest, from that whole entire process. That information is wrapped into that biochar, and then ultimately when it's put into the ground. In that entire process, when I talked about profitability, there's really no one that is in that process. We have individuals on the harvesting side and then transportation on the output. Other than that, the whole process is automated, and we can run these machines remotely. The feed and offtakes all done automatically. So that allows us to gain that element of the profitability chain. And then Cula takes over from there, and that's how we're able to track and keep track of all of our corks for sale. So with that, I'll turn it over to Oliver and let him talk about all the good things he does.
Thank you. Maybe a quick intro to myself. I'm Oliver. I'm one of the co-founders of Cula Technologies. I'll be presenting a lot of data, but still I'm the only one at the company who doesn't know how to code. So I have the pleasure of working with 17 engineers that basically do all the magic, but I'm happy to talk about it. Maybe just a reality check before we get into how we're automating things. Like, it doesn't matter if a project has an MRV or if they try to do it themselves. When you go on site, it's always the same thing. It starts with pen and paper, so producers collecting things on pen and paper. Then they give it to someone who puts into Excel. If it's done in a fancy MRV system, it has an Excel upload, which then data basically goes to the standard. And so if you want to scale this industry, that's something that we need to change. Like, this is something that works for small productions, but as soon as you get to an industrial scale, and also globally, we want to make sure that we basically scale this market safely. Now let's look into the data. So we know they're using wildfire damaged wood as well as beetle kill wood. And here, one of the buyers, like the buyers that care most about it, is this feedstock sustainability source. Like, Microsoft is really putting a big emphasis on that. So here we're using a mix of like GPS and satellite data. So when you go and collect the feedstock, you just press like auto detect location, we know your GPS, and then we can use satellite data to basically see the impact on this process. Then when the truck arrives on site, it goes into a truck scale, directly communicates to our system, and that's when we start the automatic inventory system. So with that, we know the route, so we know where it came from, we know where it went. We use the Google API to automatically calculate the transport and all emissions that are associated with that. I think it's probably best to see on this part. So here on the yellow graph, you see in real time like how your feedstock inventory is moving. So when feedstock, basically you have a new truck that's coming on, like the feedstock is going up, and then we have this integration with the feeder speed, as then feedstock is slowly going into the powerhouse reactor. There's also safeguards. So for example, in this case, we decided on 20%, but that's up for the producer to decide like, okay, at what point do I want to be notified that I need more feedstock? So it's really meant for you to focus on your operations and don't have to worry about all the little things on the sites. We also track like the moisture and like the qualities of the feedstock that are going in. At the end, that's usually the discussion point between machine manufacturer and producer. They're always fighting like, oh, machine broke down, why did it break down? And often it's a feedstock. And so making sure that the feedstock has the right characteristics, this is typically something to really make a machine run smoothly. Then to the next part. I think that's one of the most exciting part. It's actually not a fake number. So it's 444 sensors that are integrated in this project. I tried to talk to CARBO-FORCE to do one more or one less, just to make it look a bit more real, but it's actually the right number. So what we do here, you see it on the top right picture. So we have this edge devices. So it's like a microcomputer that we connect to the PLC, which is the programmable logic controller. And here we're basically able to stream all of the relevant data. What's unique about the system is it's actually offline first, and all of our software works offline first. Why do we do that? Sometimes internet comes out. Like we have it in Germany, we have it in the US, we have it all around the world, internet cuts out, and that's typically when data is lost. As you want to make sure wherever you operate in the world, it could be the most remote area, that you always have the data, because at the end, data also means carbon credits. And so if you lose the data, that's also basically big revenues that are being lost. Right there. Then I think coming to the more interesting part, with this data, you can do a lot of interesting things. So first of all, like CO2 Sync can monitor the production at all time. So here we basically focus on different temperature zones. We focus on screw speeds, different pressure zones, to really optimize how the machine is running. Like the goal is to have as much throughput as possible with the highest quality product that's coming out. Also, when you test different sorts of feedstocks, you want to know how the reactor is reacting to different sorts of feedstocks, because they can have a very large impact on your operations. With that, with sensors, we can also automate the inventory. So here we did it on a per day basis. It doesn't matter, like we've done it on super sacks, on like small 50-pound bags, to containers. Like at the end, we decide with you what makes most sense in your operations. In this case, we decided on a daily production level. So we know it all, like every day, how much biochar is being produced. What's interesting for CO2 Sync, so they actually have the option to produce 4 different sorts of biochars, because they have 4 different storage locations. So if you have specific recipes, specific process temperatures, to produce a biochar that suits one end application, that's something we can automatically track by looking to the process temperature, defining parameters. So as long as it's these parameters, it's going to be this recipe. And so also allocating different qualities of biochar automatically. It's not just for the quality of biochar, but also for the quality of carbon removal. I think that's what we really put a lot of work on recently. We're working together with Huntsman, who I would say is the leading researcher when it comes to the permanence research of biochar. So basically what we see right now is there's one lab test per year or per batch. Like a batch is typically a year, sometimes a month, depending on the standard. And so if you have just 1, 2, 3 lab tests, that's a lot of uncertainty, like how good is this carbon removal in reality. And so by focusing on machine data and like how the process is working in real time, we can also start doing more real-time predictions. So working here on a prediction algorithm with Huntsman to predict how much stable part of the biochar is part of the biochar. And with that, we'll be able to reduce the uncertainty when it comes to credits. Like typically standards reduce 18 to 25% on permanence discounts, and it's technically something that's not needed. Like we've done so far 15 tests on inertinite testing with the CARBO-FORCE unit, and all of them have been between 99.4 to 99.7. So it shows it's a really, really stable process. and has the option to really increase the revenue. And you're not changing anything. You're only changing the data that you have and the data that you display to the carbon buyers. And with that, you will be able to generate more revenues without changing the production itself. There's a bunch of, you will see this temperature curve over and over again. Like, it's really focusing on consistency. Like, it's consistency for the carbon removal. It's consistency for the product. At the end, we want to make sure that biochar, if it's used in concrete, if it's used in agriculture, it's always a consistent product, because then you can repeat results. And so that's why we stress so much about, like, how can we use production parameters to help really advance and professionalize this industry. Then to the last fun parts. So we do all kind of integrations to CM system, to invoicing system. In this case, we have the integration with QuickBooks. So when you also sell biochar, you also want to have this as automated as possible. So you create it within QuickBooks. For example, hey, we want to send out 2 truckloads of biochar today. Then the operator on site gets a notification. They know, okay, two truckloads needs to leave today. They go over the truck scale, and then you can invoice based on the specific amounts. So 2 trucks go over the truck scales. It connects back to QuickBooks, and then you invoice on the specific amounts and also specific qualities of this biochar. The last part of this puzzle piece for every good carbon removal is not just how you remove the carbon, it's also how you store the carbon. And so here it's the biochar application. It differs quite significantly if it's concrete or asphalt or agriculture. One way to do it in agriculture, it's through tracking links and GPS data. So we basically have those tracking links that you can send out to your partners, where they select how biochar was applied. We know where it was used, basically have the GPS coordinates to that, and just have some legal things like no burn agreement, the renouncement of carbon rights, so basically separating the digital from the physical goods. So basically the legal aspect is clear here as well. And as soon as that is done, we have all the data from where feedstock is coming from to how it was produced and also how it was applied. We automate, compile it, and we're the only system that has APIs to all leading standards that have APIs right now. So it's not the only standards we work with, but it's all standards that have APIs. And so with that, we're also dramatically able to speed up this process. Like, the fastest we've seen from biochar being applied to a credit was 3 days. And typically it's multiple months. And so that's something that we're also working with standards, not just do it monthly, but do it in real time, because it really just speeds up how people get their revenues. And last part, once you have a credit, it's not just a credit. It's a story behind a credit. Like, there's a way of how carbon was removed. And if you talk to buyers, many people never heard of biochar. There's like 7, 8 different methodologies, different types of removed carbon. So we created this Cula Carbon Hub to help you basically communicate your impact. So it's like a visualization tool. It's quite simple, but it's really just for you to help showcase how carbon was removed in real time. And that's really something that has been quite powerful. Like, our projects have sold to JP Morgan, to Microsoft, to Klarna, Spotify, and all those names. And it really helps getting into those conversations. And I think with that, I'll close it off for here. Thank you so much for the attention. And if you have any questions, let me know.